Multiband reconfigurable antenna for military applications. Abstract, based on compact coplanar waveguide fed frequency reconfigurable flexible antenna is presented. The design rules were proposed to use the flexible Rogers RT/duroid 5880 as a material called substrate with small size of 30*28.4 mm2. The current distribution is modified by two switches on antenna board. The resonance frequency is modified under different switch conditions, making it a frequency antenna that can be reconfigured. CST MWS simulates antenna configuration. This proposed work of antenna that contains VSWR2 and significant radiation patterns with actual gain over appropriate frequency bands. The design helps in achieving radio location in civil 4.7 GHz, amateur satellite 4.628 GHz, PMSE application 7.735 GHz, radio location 3.962 GHz in military. Keywords: reconfigurable antennas, CST MWS, switches. Introduction. Nowadays people are habituated to use a single device for multiple applications. Example: a digital watch, mobile phone, etc. Like we designed an antenna where a single antenna can be used for multiple applications, so here based on the frequency at which it radiates its application is defined. Here we are taking the reconfigurable antenna for designing and CST MWS software as medium of designing. An antenna is a series of conductors, elements, that are attached electrically to the receiver or transmitter. Antennas may be equipped to send and receive radio waves similarly, both directional, and preferentially in a common direction, headway, high gain, or flash antennas, in all horizontal directions. An antenna may include non-components, parabolic reflectors, bell, or parasite elements to direct the radio waves in a beam or other preferred pattern of radiation. A patch antenna is a low-profile radio antenna installed on a flat surface. There is a small, rectangular sheet of metal floor, placed on a bigger sheet of metal called the earth layer. A reconfigurable antenna is an antenna which can adjust its radiation and frequency features dynamically, controllably, and reversibly. Reconfigurable antennas incorporate an internal mechanism to purposefully redisseminate the radio stream through antenna to provide a dynamic response. Configurable antennas differ from smart antennas, because instead of an external stratification network, the reconfiguration mechanism is contained within the antenna. Instead of an external beamforming network lies the process inside an antenna. The reconfigurable antennas optimize the antenna capacity in a changing environment or fulfill emerging operational requirements. Figure A: conventional antenna and reconfigurable antenna. In order to ensure good gains, reliable radiation patterns and good impedance in all operating conditions, the reconfigurable antenna designs must concentrate on the following points. Which antenna characteristics, e.g. wavelength, radiance pattern, or polarization, are to be changed, and which technique can minimize negative effects in order to reconfigure the antenna output. A reconfigurable antenna provides the same features as numerous antennas. This saves on expenses, weight, quantity, and energy for maintenance and repair. The following paragraphs describe the essential antenna layout parameters. Multiband antennas can operate well over different frequency bands with a predictable radiation pattern. Nevertheless, in addition to the target frequency, multiband antennas continuously emit electromagnetic waves at all allowed frequencies. Yes, ambient electromagnetic radiation is detrimental to the well-being of humans. 2. Literature study. The proposed design generally helps in multiband applications. The widespread of new wireless technology and consumer demands for multiple services on a single device gained a lot of exposure from an antenna running on several frequency strips. 1. A frequency band is usually linked to a specific wireless service, which implies a multiband antenna is needed in a single wireless device to support multiple networks. 2. It can run several band antennas with a strong gain and stable radiation pattern on different frequency bands. In addition to the target level, however, multiband antennas can currently relay electromagnetic waves to all approved frequencies. In fact, the cellular equipment requires electromagnetic radiation 10. Frequency endurance can be accomplished by various switch sort, such as varactor diodes 3, pin diodes 2, RF MEMS 5 and FET6. Varactor diodes 1 are used to reconfigure varactor diodes, but varactor diodes are nonlinear and have small continuous tuning range 4. Switching between several bands calls for a large number of pin diodes which increase insertion loss and render the distortion circuit complicating 7. RF MEMS has a small loss, but is costly to deploy 8. 3-pin diodes for LTE, AMT fixed services and WLAN applications are used in U-shaped and L-shaped slots 9. It recommends an airborne radio frequency antenna, AMT set, WLAN, unlicensed WiMAX and X-band systems, which can be reconfigured at any time 11. By using switches that provide broad tuning of the operating bands, the productive electrical duration of the antenna is modified. The findings calculated and assessed are well known. The antenna fits well on the target bands and has strong radiation patterns. Simplicity, compactness, configurability, and versatility render it a popular wireless technology choice 12. 3. Proposed methodology. The whole process of designing is done in CST MWS. Here the antenna designing is done first, on which the switches are altered accordingly. A switch S1 and S2 off. Here coming to the process of designing. Now the two switches are involved in current transfer. The two switches S1 and S2 play a major role here. These switches are placed at inner and outer radiator respectively. The CPW feeding line is attached to the central heater with a diameter of 1 mm. For switch S1 and S2 the interior and exterior heaters are connected with the central heaters. First of all, it is designed to feed CPW rectangular antenna with a single 4.8 GHz channel. Within and around the central radiator, the triangle is added to achieve additional reflection frequencies whose results are shown at figure 1. Now extending the implementations with switches operations is shown from here. With these implementations the antenna and their results are shown below. Both switches are S1 and S2 are put off. Figure 1. Reconfigurable antenna when S1 and S2 is off. So after the simulation of above design we get the following result. Fig.1, A, S parameter when switches S1 and S2 are off. The antenna simulates at 4.7 GHz which has aeronautical radio navigation application. So by varying the switches positions later the remaining applications can be notified where it proves that multiband applications on single antenna. B switch S1 on and S2 off. Here switch S1 is kept on and switch S2 is kept off, which is shown below. Figure 2. Switch S1 on and switch S2 off. When switch S1 is on and switch S2 is off the current radiates in inner radiator and radiates at frequency of 4.628 GHz. Figure 4. Switch S1 on and switch S2 on. Figure 2, A, S parameter when S1 switch on and S2 switch S2 off. Now the antenna radiates at 7.7352 GHz and 3.9311 GHz. Here we observe that S parameter is shown as above. The respectively. Here the parameter results show that antenna radiation frequency at 4.484 GHz has radio radiates in multiband manner, that is at 2 points. The S determination application parameter results are shown below. See switch S1 off and switch S2 on. Now switch S1 is put off and switch S2 is put on. So current circulates through S2, that is at the outer radiator respectively. This is clearly shown below. Figure 3. Switch S1 off, switch S2 on. The antenna radiates at 3.962 GHz and 7.759 GHz respectively. Here it radiates in multiband manner. The S parameter results are shown below. Figure 4, D, S parameter result when S1 is off and S2 is on. 4. Results. From 3, A, 3, B, 3, C, 3, D, observations say that antenna radiates at different frequencies based on switching positions in 4 different ways. The obtained results are tabulated below in overview. Table, outputs. Figure 3, A, S parameter when S1 is off and S2 is on. D now with switches S1 on and S2 on. Yes, now switches are fixed and put on. Here when both the switches are kept on, the antenna radiates at certain frequency of 3.384 GHz respectively. Now the current circulates at main radiator only. This can be observed below. Conclusion. The reconfigurable antenna design here is for purpose of multiple applications. The lightweight modular and frequency reconfigurable antenna is built, developed, and defined. The same is replicated using a CST Studio software simulation tool. The 4 frequency bands were obtained in this antenna, where it promises that antenna radiates at different frequencies with the applications such as radio location 3.962 GHz in military, amateur. Satellite 4.628 GHz, radio location in civil 4.7 GHz, PMSE application 7.735 GHz in accurate manner.